So now that I've given you an overview of the kind of the overall behavior of the ImageTaskGang application, let's talk about its structure and its dynamics. And we'll do this through the use of a couple of different techniques. We'll show some UML class diagrams and their relationships, and we'll also kind of walk through the code at a higher level using a dynamic object interaction style diagram to guide our analysis. So let's take a look first at the structure of the ImageTaskGang application. So we have a UML class diagram that shows the key components in this application. These are the classes that I've highlighted here that implement the application's concurrency engine. Those are the things we really care the most about. And we'll start out with something called a task gang, and it defines a framework for spawning and running a gang of tasks that concurrently process input from a generic list. And the use of the word gang, it's kind of an outdated term. It's been around for a long time in the context of scheduling and concurrency. Don't think of this as a negative. Think about it like the Washington team from the 70s that had the over-the-hill gang, which were players that were perceived as being older than the norm in the NFL, but they bonded together as a unit to come and win some Super Bowls, and that was their title, the over-the-hill gang. So it's really meant to be things that collaborate together to get interesting things done. We also have an ImageTaskGang, which customizes the TaskGang framework for image processing, and we'll see when we look at the code that involves overriding a bunch of abstract methods and then making sure that those abstract methods do something specific to image processing, which is the focus of this particular application. And the ImageTaskGang uses the executor completion service, which is a concurrent Java class that will implement the proactor pattern. And we'll talk more about the proactor pattern momentarily when we do the next section, the next part of this lesson. But in a nutshell, it's basically a pattern for doing asynchronous invocation and processing of operations in a pool of threads. There's also an image class, which stores metadata about an image and enables image processing. We'll see how that works. Very important class for the ImageTaskGang. And then finally, we have a hierarchy of classes rooted in the filter class, which implement image filters using the gang of four decorator pattern. And again, we'll talk more about these patterns in the next part of the lesson, but I just want you to kind of see the big picture view before we start diving into details and looking at source code and so on. So now that you have a fairly good idea of the structure of the ImageTaskGang application, let's explore the dynamics. So here's an object interaction diagram, a bit colorful, showing the ImageTaskGang application and the way in which various methods are called over time. There's a whole bunch of steps. There's roughly about a dozen steps that are used by this application to download, process, store, and display images that are received from either web servers or from some configurations local to the device just for testing purposes. So we'll start out by the first part here. There's a run hook method on the ImageTaskGang class itself that when called will obtain the list of URLs that are needed, and then it creates runnables that will that'll be processed concurrently using Java's executor completion service. So that's kind of the high-level view here. There's a getNextInput method that's part of the TaskGang framework that must be customized by subclasses, in this case, ImageTaskGang, and it's used to get the next tranche of URLs to download concurrently. So you can see that getNextInput is going to get the next set of URLs. And we do this as a framework to make it easy to customize and override the behavior for different styles of applications. There are other examples, for instance, that use the TaskGang framework for things other than image processing that you can find in my GitHub repository. The InitiateTaskGang method is called via the run hook method to create the appropriate type of thread pool. And in this particular case, we're going to create a fixed size pool of worker threads. There's another kind of case as well. And so what will happen here is once we've created that thread pool, we're then going to be able to execute tasks. Each task is a runnable. We're going to be able to execute those tasks by scheduling them with a work queue for subsequent processing in our fixed size thread pool. You can see that on the right-hand side. We have a pool of threads, which is fixed. We typically, in this case, have as many threads as there are processor cores. We could make it more dynamic, but let's stick with something simple to begin with. One thread in that fixed size thread pool will dequeue each of the runnables from the work queue, and they will then call the run hook method on that runnable. And what that will do is that will trigger a call back up to the application level, to the ImageTaskGang application, to call the process input method. And process input, in turn, is going to download content, and then it'll apply a list of filters to the content that's been downloaded. Now, the way that the list of filters are applied is for each filter operation in the list of filters that will be submitted via a callable Lambda expression back into the executor completion service and its fixed sized pool of worker threads. So it gets submitted, that gets put back into the work queue as we just saw before. So it's scheduled for execution by putting it onto the work queue. And then one of the threads in the fixed size worker pool will go ahead and take the message off the work queue, take the runnable off the work queue, which is actually a callable in this case, and it'll invoke the Lambda's call hook method, which will then filter the image that's been downloaded previously, and then it'll store it in a local file. Now, once it's been stored in the local file, it's also added to the executor completion service completion queue. And when it's been put in that queue, then the application can come along and take it, and that will allow it to be able to be removed and displayed. So the main thread is responsible for sort of kicking things off and initiating the asynchronous processing by the executor completion service using the proactor pattern. And then it also is responsible for retrieving the results, processing them, after they've been processed asynchronously, and then displaying them. So that's the walkthrough of the interaction diagram for the ImageTaskGang application. This should make it much, much easier to understand the source code when we walk through it, because you would have seen the bigger picture. And I'm a big fan of visualizing, whenever possible, how concurrent code works. I find it's too hard often to make sense out of it by looking at source code alone. So that's the end of our part of the lesson on the structure and dynamics of the ImageTaskGang application.